responsibility of data link layer, the encapsulation responsibility. Encapsulation is the process of adding a header and a trailer to the data as it moves down the OSI layers. At layer 2, the protocol we configure, whether it's HDLC or PPP, defines the specific format of the frame. A protocol is simply a set of rules that decide the communication. If two devices are configured with different layer 2 protocols, they are effectively speaking different languages and cannot establish the connection. Our choice of protocol therefore determines the feasibility of a link and the features available for the connection. So the data link layer can encapsulate frames in two different formats. First is the HDLC. HDLC or high level data link control is a well established layer 2 protocol. In Cisco environments, it is the default encapsulation protocol for serial interfaces. However, it's important to note that Cisco's implementation is proprietary, means it will not interoperate with HDLC from other vendors. So devices from Cisco alone can use the proprietary version of HDLC. So this is a limitation of HDLC in Cisco devices. They cannot interoperate. Also, HDLC lacks built-in authentication, making it unsuitable for unsecured connections. So the data will be exchanged in plain text format. So there is a chance of uh, uh, security breach. So then the second encapsulation method is PPP. PPP stands for point-to-point protocol. It is a global standard. So this makes it vendor agnostic, allowing for interoperability between different brands of networking equipment. More importantly, PPP was designed with enhanced functionality in mind, including support for authentication protocols like PAP and CHAP. PAP stands for Password Authentication Protocol and CHAP stands for Challenge Handshake Authentication Protocol. So in today's class, we'll see the implementation of PPP with PAP. So to summarize the differences, we can compare them on three key objectives or aspects. HDLC is vendor specific and offers no authentication, while PPP is standard based and provides robust authentication capabilities. Also, HDLC is simple and has minimal overhead, whereas PPP's additional security features provide greater security and flexibility at the cost of slightly more complexity. So now let's see the practical demonstration of HDLC and PPP in Cisco Packet Tracer. So I placed two routers, 2901s on the workspace. Also two PCs, PC0 and PC1 on both sides of the routers. Now let us set a serial connection between the router 1 and router 2. So you can click the connections icon, select the serial DCE, choose a serial interface on router 1. So on 2901 there are no serial interfaces. So first we need to add the serial interface. So click on router 1, the physical tab, turn off the device first and then select the serial interface, drag and drop to an empty panel, then turn it on. You can see the router reboots after you switch on the power button. It asks for a default setup. So click no, select no. Do the same on router 2. So go to the physical tab, turn off the device, select a serial connector, drag and drop into an empty panel, then turn on the device. Let the device boot. It asks for an initial configuration, so no. Now we will configure the interfaces on the router. Select the serial interface DCE. Now R1 has a serial interface on it. Select the serial interface or connect the link to the serial interface on router 2. Then we access the command line interface of the first router. Then enable configure terminal. Now select the serial interface, serial. So the interface to which the connector is connected to is 1 minute. Serial 0/3/0. So 0/3/0. So now we have selected the serial interface. I give a valid IP address on this network. So this network have the network address 192.168.1.0. So I'll use the first usable IP address IP address 192.168.1.1. Subnet mask 255.255.255.0. Then we'll select the encapsulation as HDLC. Anyways, HDLC is the default encapsulation mode. So now, because we have connected the devices using DCE serial connector, you will have to observe the serial connector side which shows a clock. See here, I can see a clock symbol. So the interface on router 1 has a clock symbol, but the interface on router 2 doesn't have a clock. So you have to set the clock rate on router 1. Set the clock rate as 64,000 and then try to bring it up. You can see the interface is now down because we haven't configured the other side of the interface on the router 2, other side of the link on the router 2. So now you can exit here, repeat the same on router 2, click on the CLI, enable configure terminal, select the serial interface 0/3/0. Now give a valid IP address on the network. IP address 192.168.1.2 255.255.255.0. Now choose the encapsulation as HDLC and then try to bring it up. Now the interface is up. You can see the indicators turned green. So to test the connectivity, we will use these PCs. We will set the IP addresses of these two PCs on different networks. PC 0 is on the network 1, 192.168.10.1. PC 1 is on network 192.168.20.0. So let me choose a copper straight through cable. Connect the PC's fast Ethernet to the router's gigabit Ethernet port. Choose the copper straight through PC's fast Ethernet to router's gigabit Ethernet. Now let us also configure the interface to which the PCs are connected to on both the routers. So select the interface gigabit Ethernet 0/0. Now choose an IP address on this network. IP address 192.168.10.1 and the subnet mask 255.255.255.0. Try to bring it up, no shut, and the interface status change to up. You'll also have to give a valid IP address on this network for this PC 0. Desktop IP configuration 192.168.10.2. Subnet mask appears by default, and the gateway's IP address should be the IP address that we assign to the interface on the router. So it is 192.168.10.1. So the gigabit Ethernet is 10.1. Okay. So now on PC1, repeat the same. Desktop 192.168.20.2, 192.168.20.1. Choose the gigabit Ethernet interface. (0/0). Now assign the IP address 192.168.20.1, 255.255.255.0. Now we'll try to bring it up, no shut. See the status changed to up. So now both the PCs have a valid IP address in their networks. Also the interfaces that are connected to the PCs are also configured accordingly. But then the PCs won't be able to reach each other even though the configuration is seems to be complete. So let me check ping 192.168.20.2 from PC 0. This will be unsuccessful. The reason being R1 has no clue that the one of the interfaces on router 2 have this network ID, and same applies to R2. R2 has no clue that R1 has an interface configured with this network ID. So we will have to let the routers know that there is a network configured on some other router's interface with a specific network ID. So I will go back to the global configuration mode. Choose the IP route 0/0/0, the default IP route. Should reach the interface on the router 2. Okay. So the interface on the router 2 is 192.168.2.1. We will do the same on router 2. Go back to the global configuration mode. Set the IP root 0/0/0/0, sorry, 0.0.0.0 to 192.168.1, sorry, 1.1. So on router 2 it is 1.1, and it is, I think it is 1.2. 1.2. 1.2. Now let us test the ping. See, the ping is now successful. PC0 is now able to reach PC1. Next we will configure PAP, the password authentication protocol on routers. Now let us first switch to PPP and then try the password authentication protocol and the challenge authentication protocol, challenge handshake authentication protocol. So switching to PPP, the initial configuration is quite similar. We apply the IP address and the no shutdown command on the serial interface, but then the encapsulation should be set to PPP instead of HDLC. This is the only difference in the basic configuration in the command encapsulation PPP. When the link is established, a quick check with show interfaces will show both the physical link and the line protocol as up. So first let us see the interface on router 1. Move to the privileged mode, show interface serial 0/3/0. So you can see the encapsulation is default set to HDLC on router 1. Same applies to router 2. We will change this encapsulation to PPP first. Configure terminal interface serial 0/3/0. Now the IP address on router 1 should be 192.168.1.1. No change in IP address or subnet mask. We will be using the same IP addresses, but sorry, so it should be 255.0. So now let us switch the encapsulation mode to PPP. You can see the interface status is now changed to down because the router 1's interface is now changed to encapsulate on PPP, but router 2 still operates on the HDLC encapsulation. So because there is a mismatch, the interface status is changed to down. Also on router 1 we have the clock symbol, so you have to set the clock rate to 64,000. We'll try to bring it up, but it won't happen now itself. We have to do the same on router 2. So interface serial 0/3/0, IP address 192.168.1.2, 255.255.255.0, encapsulation PPP, and no shut. Now the status is changed up because we configured PPP on both the interfaces. Now you can go back to the privileged mode and then run the command show interfaces serial 0/3/0. So the encapsulation is now PPP on both the routers. So there are two authentication protocols that can be configured on PPP connections. So one is PAP, second is CHAP. PAP stands for Password Authentication Protocol. So this is a simple two-way handshake protocol. The client sends its username and password to the authenticator, which verifies the credentials. The password is sent in plain text, which can be a problem. This might make the passwords vulnerable to eavesdropping and security attacks. So because the passwords are unencrypted, clear text exchange happens and a hacker can easily capture the credentials using a packet sniffer. So it's essentially like sending your password on uh, plain text. So first let us see how PAP works. I will move to the router 1, enter the global configuration mode. We are already in global configuration mode. I will change the host name to R1. So now you can say the prompt shows the new username, the new host name as R1. Now I will let the router 1 know the username and password of the router on the other side of the serial interface. So username on the other side of the link, let us rename the router 2 as R2 and we'll use the password Cisco. This password can be anything, any valid identifier. Now I'll move to the interface serial 0/3/0 and change the encapsulation to PPP and then set the authentication to PAP. So you can see again the interface is now changed to down. The status has changed to down. Because on the other side of the serial interface, you don't have a router with this username R2. The username is yet to be configured on router 2. So the status is now down. Let us try to bring it up. Repeat the same on router 2. Enter the global configuration mode. Then change the host name to R2 and let R2 know the username and password of the router on other side of the interface. Username R1, password Cisco. Now go to the interface serial 0/3/0 and change the encapsulation to PPP and let PPP use the authentication PAP. You can see the interface state has changed to up. You can exit from here. Now assuming that the routers will exchange data, let us try the ping test from PC0 to PC1, but it will be unsuccessful. Even though the link shows the status is up, the ping will be unsuccessful. See, the ping is unsuccessful. So to enable the connectivity, the routers will have to exchange their usernames and passwords with each other. So again, go back to the serial interface. Then send the username and password of router 1 to router 2. So I'll use PPP PAP send username R1 and password Cisco. So we are letting R2 know that the device on the other side is aware of the username and password and is the correct device. So if you connect some other device, then there is no chance that the usernames and passwords are known to it. So there can be a mismatch in the username and password. So now router 1 have said router 2 that this is my username and password. Let us also do the same on router 2. Router 2 should inform router 1 that the username and password of router 2 is so and so. So I will move to the serial interface first. 0/3/0 and then we have already set the router names, usernames and passwords. So I will directly run the PPP PAP send username R2 and password Cisco. See, now the interface status has changed to up. Now the ping has to be successful. So PC0 tries to ping PC1. So it is 20.2. See, the ping is now successful. So we have examined the Cisco's HDLC encapsulation and PPP encapsulation. Under PPP, we have used the password authentication protocol. So this password authentication protocol makes use of the usernames and passwords to authenticate the network devices on both sides of the serial interface, because the serial connector may use the internet to transmit the data in between. So exchanging passwords in plain text may be vulnerable. we will try to overcome the vulnerability in PAP, the password authentication protocol, using challenge handshake authentication protocol in a different video. Thank you.